Hi guys, myself Martin. In this video, we shall see another problem on LeetCode. Find duplicate number. So given an array of integer nums containing n plus 1 integers where each integer is in the range 1 to n inclusive. So there is only one repeated number in nums and return this repeated number. So you must solve the problem without modifying the array nums and use only one constant extra space. So given the problem is that they are given an array of integers that contain integers. Among these 1 to n elements, one element is repeated twice. So let's say 2 is repeated twice somewhere in the array. So we have to identify this repeated number in the array. And the given constraint is you must solve the problem without modifying the array numbers. So you cannot sort the array or anything. With the existing array, you have to find the um, repeated number and you have to use only one constant extra space. So if there was a chance to modify the array, then we could have sorted the array in the ascending order. Like you might get 2 comma 2 here and 3, 4, 5, 6. So you can compare the adjacent position elements and if anyone which becomes equal, you can return that. That was the case if we did not have any constraint like without modifying the array. So here you cannot modify that. So other approach can be we can use hash map. So in hash map, check if hash map name is map. If map dot contains key of nums of I. If this particular element is not present in the hash map, then you add that to the hash map. Map dot put of nums of I, comma 1 you can put because it's the first occurrence. Otherwise, what if you get map dot contains key of nums of I? Then you just have one variable called val and assign that val to this nums of I. That itself is a repeated number. That's it, you can return that. But this is not the optimal approach if you see. So what is other best approach is we have seen the linked list cycle problem previously. So we'll implement the same approach here. For the explanation of that linked list cycle approach, you can refer the video. I'll put that in the description box. You can check out that. So with that approach, we can solve the problem. So that approach is nothing but tortoise problem. Like we'll have two pointers, slow and fast. So slow, as you know, it will move by one position, and fast will move by two position. And once you refer that problem, come again to this problem here. So that will have all the numbers like many numbers. And we know that as the slow pointer moves one position, so as the fast pointer completes one cycle in the array, slow pointer will complete only half of the portions of the array. So that is the case because fast is twice of the slow. That's why. So that is the logic behind it. We will apply the same logic here in the this question as well. So let's take example of 313 3 comma 1 comma 3. One thing before this we know here, as I said, as a slow completes half of the array portion elements, fast will complete one round, right? So at this time, slow will be like some at some point in time, like both slow and fast will collide. So let's say that position be this slow and fast collides. So by this time, when you both slow and fast collide, slow becomes equal to fast. Then reinitialize fast to the new position, zero position, and slow here itself. Now from here, equal amount of steps it needs to move to get the array that is repeated in the to get the element that is repeated in the array. The element which is repeated in the array can only have form a cycle here. So please do refer to that video. We'll get a very good clear idea upon how the problem solved is. So here, how to perform the cycle is based on the index of the array. So let's take an array example. Okay, I have taken the example list array with the index position 0 to 9. So let's start with first now. So for creating the cycle, we start with first element 5. So go to the 5 index. What element is present? 3. 5. Okay, next go to 3 index. What element is present over here? 6. Next go to 6 index. 9 is present. Similarly, go to 9. You will find 7. And then go to 7. 8 is present. Go to 8. 1 is present. Go to 1. 2 is present. And if you go to 2, let me just erase this. Okay, 1 is present here. If you go to 1, 2 is present. So if you go to 2, 4 element is present. So if you go to 4, 3 is present. So this is how we form the cycle. Now we do slow and fast pointer and we move slow by one position. No, this might be slow. Then fast by two positions. So this is how we transform the array into linked list cycle. So once you get like at this point, if you find slow equal to fast, then your initial fast here and slow will be here itself. So from here equal position it has to traverse. So the reason why it has equal position it has to traverse is I have given explained in the video of the linked list cycle. So refer that. So here for this array 31342, then yeah 31342. Here for this array same thing we apply. Like we start from 3, then go to the index 30123, that will find you 4, then go to index 40123, that will give you 2, then go to index 2, that will give you 3. So this is how we form the cycle. So same logic we apply in the problem. So until you will have slow and fast pointer, so slow will be initialized to nums of 0 and fast will be initialized to nums of 0. So until you get slow equal to fast, what you do? So slow equal to nums of slow you do and fast equal to twice of the fast. So nums of fast. Once you found this slow equal to fast, you will have slow and fast at some value with that. So now from here, as I said, fast should be reinitialized to the zeroth value. So fast will be equal to nums of 0 again, and slow will be this itself, whatever you found here. From there until slow is equal to fast, we get this value. What you do? You do slow equal to nums of slow equal to nums of slow, and fast equal to nums of fast. So this condition is for here what I told. You initial is fast to zeroth value and slow from here. Equal distance you have to traverse to get the value, repeated value. So the reason for this equal traverse distance is explained in the linked list cycle video. So we'll code this. Initially we will have int slow equal to nums of 0 and int fast equal to nums of 0. So next, so initially both are equal now, so we have to give do condition. Slow equal to nums of slow and fast equal to nums of fast. So while give the condition here, slow not equal to fast. So why are we doing do while condition? Because initially slow and fast are equal. So if they're equal, then this won't execute only. So initially you do nums of slow, then you do nums of fast until slow not equal to fast. Next reinitialize fast equal to nums of 0. Again give while slow not equal to fast, slow equal to nums of slow, and fast equal to nums of fast. So at last, return any value. Slow. Yeah. Yeah, successfully submitted. I hope you guys have understood the problem. If you have any errors, please drop in the comment section and please like the video and subscribe to our channel and keep learning. Thank you.